The Naked Scientist podcast, powered by UK Fast, the UK's best hosting provider, on the web at ukfast.net.
Hello. This weekend, we're talking about the science of plants, we're talking about the science of climate change and how it affects migrating animals, and also we're talking about how a weather forecast gets put together. If you have any questions on that, call now 08459 925 2000, text in on 07786 20 1960, or email chris@nakedscientist.com. Also here in the studio to help with tonight's show is Helen. Hi, Helen.
Hi, Chris. Yes, and as always on The Naked Scientist, we'll be giving you a rundown of the latest news in the world of science, technology and medicine. So this week we'll be finding out why it is that teenagers are so terrible to live with, and how gold nanoparticles are letting scientists peer right inside living cells for the first time. And we'll be giving some good news this week for any dinosaur spotters out there.
And of course, if you're in an experimental mood, there's Kitchen Science. Stay tuned to find out what we want you to do this evening. And first person through with the correct observation will win one of our fabulous prizes. And also, if you have any science questions on anything, I'll be giving you the phone number very, very shortly, so grab a pen and paper to catch up on that. But to get the ball rolling, here's this week's teaser question. The ozone hole has been caused by CFCs. But what are CFCs? What does CFC stand for? If you know the answer, 08459 25 2000, email me chris@nakedscientist.com, or text in on 07786 20 1960.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientist.com.
And yes, coming back to kitchen science, I think if anyone out there is in an experimental mood, you will need to get out 3 bowls. Fill one of them with iced water, one of them with warm water, and one of them with tepid water. Stand by and we shall let you know what to do with them very shortly.
Now, Helen, last week you might remember we had a call about cows in fields, and I got an email here from Rick Fawcett, who's in Australia, and he says, quick question, this was raised on the podcast from the 3rd of September about why cows tend to face the same direction in a field. I heard this while driving from my farm to the gym here in Australia, and I could see cows in neighbouring fields and they were all facing in random directions. I suggest that cows and other farm animals tend to face away from the wind and bad weather. As we were having a calm and rather fine spring morning here, the cows had no need to face away from the wind. This might be an additional answer to the ones that you gave on the programme, including someone's suggestion that it's because if cows are facing into the wind they can't burp and this could kill them.
Yes, we'll have to see on that one. But from cows to dinosaurs. So great news this week for any of our listeners who are budding paleontologists. There are still plenty of dinosaurs out there to discover, never fear. This is according to a new study by Steve Wang, a statistician at Swarthmore College in Pennsylvania, and Peter Dodson, a paleontologist at the University of Pennsylvania in the US, and they looked at the number of skeletons found so far from each known dinosaur genus. And genus is the group a bit bigger than species, so humans are Homo sapiens, which means we belong to the Homo genus and the sapiens species. Now, this team is plugging away with these dinosaur numbers they're plugging the numbers into an established mathematical model which links the fossil sightings to the likely number of unseen dinosaurs. And they've predicted that there could be a total of about 1,850 genera of dinosaurs left in the world in total, and we've only found 527 of them so far.
So where are they all lurking?
It seems, I think China and Argentina apparently, where lots more recent studies, dinosaurs are being unearthed, and that's been a source of lots of the new ones that have been found. Apparently in the last 20 years we've found twice as more dinosaurs than we knew before then, and maybe Africa might be a new place to start looking for them. We won't ever find every last dinosaur because not all of them will have left fossils behind for us to find. But the good news is that around 90% of the dinosaurs that are discoverable will probably be found in the next 100 to 140 years. So if you're hoping to discover something fiercer than a T-Rex or something bigger than a Giganotosaurus, then it's definitely still worth getting out there to have a good look for it.
Do you get to give your name to it then if you discover it?
I think that's quite bad at the moment. I think it's quite bad press in the science world to give a name after yourself. I think you have to get someone else to name after you, perhaps if you discovered it, and hand it over to someone else to describe, perhaps.
So as a marine biologist, if you discovered a new species of fish, Helen, you wouldn't name it after yourself?
I don't think so. I think it's better, especially if you're working like I do a lot in the tropics, to maybe name it after the place you're in.
She just had to drop that in, you see. Yeah.
Make it a bit more local to where you found it, or perhaps people you worked with. It's a bit kind of big-headed to call it after yourself, I think. But
now, teenagers get a bad rap, don't they? They're viewed as very difficult to live with. They're viewed as extremely argumentative and a bit of a pain in the backside. But it turns out that it could well not be their fault, because Sarah Jane Blakemore, who works at University College London, thinks she's found the answer to why teenagers go through this difficult phase in their lives. And she did this by brain scanning clusters of adults and also groups of teenagers, and when they're in the brain scanner, she asked them to do simple memory tests and simple sort of cognitive tasks in which they were asked to think about or plan an action and also think about how it might affect other people. And what was really interesting was that there were two areas of the brain that lit up when she did this study, and the first area of the brain was a region called the superior temporal sulcus, and this area is just concerned with planning things out and literally executing things. Not people, obviously, but doing tasks. The other area of the brain is the prefrontal cortex, which is right at the front of your head and is concerned with considering the consequences of what you do. Now, in the teenagers, just that area in the superior temporal sulcus lit up, showing that they understood the task and they were quite happily planning it out in their mind. But they weren't thinking at all about the consequences of their actions, whereas the adults showed much stronger activation in this consequence area right at the front of the brain. So the sort of bottom line here is that adults seem to consider the implications of their actions far more than teenagers do, and this is something that improves with age. And when she got the same group of people and then asked them to just think, if I had told you to do the following, how would it affect other people, and then timed how long it took them to respond, the adults all responded much, much quicker. So this is something that we gain as we get older, and we gain more of a conscience as we get older. So that might explain why teenagers are badly behaved, why they're hard to get on with, but at the same time can't be blamed because it's not really their fault.
Do you think it's going to help us get on better with teenagers? I, for one, was a very well-behaved teenager. I'd just like to point that out. Now, last week at the BA Festival of Science in Norwich, I went to a session all about should we eat fish, and they brought up all sorts of arguments for and against the eating of fish. But a new report out this week unveils that nearly half of the fish that we eat today haven't been caught from the seas and rivers and lakes of the world, but they actually began life in a farm, just like the beef, pork and chicken that we eat. And this is a report from the UN Food and Agricultural Organization, the FAO, and it describes basically a massive boom in the amount of fish that we're farming, a process known as aquaculture. In 2004, we were growing 45 million tonnes of fish compared to 60 million tonnes, which are being taken from the wild. And this all basically surrounding the fact that as the number of people in the world climbs ever higher and we are having more and more demand for fish, we aren't actually catching any more of them from the sea. And in fact, even though we're getting bigger boats and better fishing gear, we're still catching exactly the same amount of fish that we were for the last couple of decades. So the question is farming fish a good or a bad thing? And that doesn't seem to be a very clear thing either. We've got many reasons why it might be bad. Diseases, parasites get out into the wild. There's genetic contamination from those farmed fish, and fish farms can generate a lot of water pollution. But the positive side is also that there are countries which may be really benefiting from farmed fish because they're getting a very secure source of food in the developing world. And maybe it's even going to help out some of our endangered species. Like, for example, do you know that we're now farming cod?
I didn't actually. I thought they were too difficult because they're absolutely huge and they take years to mature.
It is a very difficult thing to farm, but they are just figuring it out. And up in Shetland, there is a company that is starting to grow cod. So you might actually be able to have sustainably grown fish for your fish and chips and fish fingers. And maybe even one day the Japanese will be farming bluefish tuna for their sushi.
But with something like that massive kind of animal, Helen, how do you farm it? Is it an enclosed area?
Yes,
or is it...
you can have sort of sea pens, really, sort of floating cages in the ocean. I mean, these animals, migratory animals, yes, are going to be very hard to keep in cages. But the cod seems to be getting on, and they are. I've seen them. In fact, it was on a TV programme on the BBC a few weeks ago, Sea-Watch, I think, if you saw that. And Kate Hummel was actually diving inside the cage with the cod, and it was enormous, a great big cage.
Laying the facts bare, the Naked Scientists.
OK, experimentation time now, and this week Derek and Dave are at Hinchingbrook School, where student helper Daniel is preparing to get his hands wet in the name of science. Hi, Derek.
Hello there. This week we are in Hinchingbrook School, so welcome to you, and we've come here to do an experiment which is extremely easy and which you can do at home, so please listen out. And of course with me is Dave, who's going to tell us what it is we're going to be doing. So what is it we're going to do?
We're going to be confusing your senses with just 3 bowls of water.
There you go. We're going to be confusing your senses, and you too at home can confuse your own senses. And willing to do this for us here is a volunteer from Hinchingbrook School. Could you just tell us your name and what year you're in?
Hi, I'm Daniel, and I'm in Year 12.
OK, thank you very much. And also, do you do science? Are you into science?
Yes, I do physics AS.
OK, anything else to add? Or
I do find it quite interesting from time to time, so some things are good.
All right, then. OK, well, hopefully we'll be giving you some good science to kind of be really interested in today. OK, then, so let's just start with what you need at home. What you need is 3 bowls, OK, and these bowls have got to be quite big. Also, if you've got washing up basins, then that's fine. That's actually what we've got here. But the bowls should be, let's say, 8 inches across at least, big enough for you to put a hand in. And then you've got to have some water, basically, hot and cold water. And what is it you've got to do with these things, Dave?
You've got 3 bowls. You want to take one of them and put hot water. Be careful it's not too hot and you injure yourself. Another one, put really cold water in. And one in the middle wants to be a mixture of the two, nice sort of middle temperature water.
OK, then, so if you get water from the hot tap, then just do be careful that it's not too hot and then it scalds your hand, because it can sometimes come out very hot and you will be sticking your hand in it if you do this experiment. And then, of course, a bowl of cold water as well. And what's a good way just to make it, really cold?
We just added a little bit of ice, not too much, but just a bit.
OK, that's fine. And so what do you then do with these 3 bowls of water?
OK, you put one hand in hot water and one hand in the cold water for maybe about a minute or 2, and then take both of them out and put them in the middle of water and see what you feel.
OK, so you've got to tell us what you feel in each of your hands. So one hand's got to go in the hot, one hand's got to go in the cold, and then keep them in there for the same amount of time, about a minute is fine, and then put them both into the middle temperature of water and tell us what you feel. And Daniel is going to be doing this for us a little bit later on in the show when we come back to the school here in Hinchingbrook. But Daniel, what do you think is going to happen? What are you going to feel?
Well, I don't know. It might both be the same, maybe.
All right, OK, well, we shall find out. So anyway, that's what's going on here in Hinchingbrook. If you'd like to do this at home, then please do call us or email us, basically, because if you can get the right result and tell us what happens, then you can win a prize from us, the Naked Scientists. So the number is 08459 25 2000, and you can also email chris@thenakedscientist.com. So we'll be back here in Hinchingbrook School in a little while to find out what happens with Dave, Daniel and myself. Until then, it's back to the studio.
Thank you very much, Derek. It is Chris and Helen here with the Naked Scientists, and later on in the programme we'll be catching up with Beverly Glover to find out how plants have evolved their own form of solar panel to make themselves even more alluring to pollinating insects. That's still to come. And also we'll be talking to a real-live weatherman, John Law, from WeatherQuest at the University of East Anglia, to find out how the weather forecast is actually put together. And Marcel Visser will be joining us from the Netherlands Institute of Ecology, because he's interested in how global warming could be affecting how animals that migrate actually mate and reproduce, because there are major problems happening now, because animals that are migratory like birds are arriving back in the right part of the world at the wrong time, and they're missing what would normally be their sort of food staple to help them have young. Major problem, or is it? And how can we get round it? That's Marcel Visser coming up later on The Naked Scientists.
I've got an email here from Rebecca in Wisconsin in the States, and she says, here in the States, when we're out at the bars and someone wants to be funny or annoying, they use the bottom of their beer bottle to tap the top of someone else's bottle, which makes the victim's beer fuzz up and overflow. Can you tell me the science behind this? Now, I have had this done to me, and it's very annoying, but I'm... Chris, any idea what that's about?
Well, it's similar to a question that we discussed not so long ago, Helen, isn't it? Where someone from Australia, I think, actually said, why is it when you go and get a can out of one of those can dispensers and it seems to plummet to the bottom of this machine, and you open it, it just goes psst, and it doesn't explode all over you.
Whereas, thank you very much. I'm glad it doesn't. That would be...
Yeah, exactly. But why is that? And Dave and I were discussing it, and what we thought was, well, when the can falls, it tends to spin. And so it lands on its side with the liquid spinning in a circle inside the can rather than striking the top of the can. And because it's going round in a circle and the inside of the can is very smooth, what's probably likely to happen is that the fluid doesn't come into contact with any rough surfaces, so there's nowhere for the gas to nucleate or form tiny bubbles. So there's no way for it to actually form a big layer of foam, and therefore it doesn't want to explode.
I wonder if they figured that out first before they went and designed the machines, or is it just a happy coincidence that we aren't covering ourselves in fizzy drink every time we get a drink out of the machine?
They must have done, because it would have been a marketing disaster, wouldn't it? If you were to get covered in a can of whatever every time you bought one. But to go back to the bottle, I think what could be going on here, of course, once the bottle is open, there's no pressure inside. So the gas that's dissolved in the beer, the carbon dioxide that makes it fizzy and frothy and refreshing, if that wants to obviously come out, which is why you've got the little bubbles forming, if you smash the top of the bottle hard with another bottle, it makes a shock wave. And I think that shockwave is enough to start some nucleation, in other words, a formation of some tiny bubbles inside the drink. And once you've got one bubble formed, it forms a site for more to form on, so then the whole thing sort of feeds back on itself. And these beer bottles have a very narrow neck, so as soon as you make a little bit of foam, the foam very quickly blocks the neck, and then the whole thing has nowhere to expand, and so it just pushes everything out in a massive, great volcano, if you like. I reckon that's what's going on.
OK, Rebecca, well, I hope that helps to answer your question. And remember, if anyone else has any questions at all for us today, we're here in the studio waiting for you now. Give us a call, 08459 25 2000, or give us an email. I believe it's chris@nakedscientist.com. And it's always good to hear from you. I've got an email here from Jan Hope, who says, please ensure that there's another radio series. I can simply not survive without my podcast of the show. So thank you very much for your email. And we do love to hear from you. So as I said, keep the emails coming. And we love to know what you're thinking about the show and any questions that you have.
This one's quite funny. It's from Cheryl Murphy. She's an optometrist, she tells me, from Long Island in New York. And she says, just started listening to your podcast and I'm officially addicted. I even listen to them with headphones on in my car through my iPod. Yikes! I think a Naked Scientist T-shirt is in order. Can we have a store so you can get some Naked Scientist sort of gear? Well, that's a good idea, isn't it?
I think that's a great idea.
Got an email here from Roland Brown, who's in Toft in Cambridgeshire. He sent me this a little while ago and I haven't had a chance because we've been off air to answer it, so I'm going to do it now. Perhaps you can help me, Helen. He says, hi team, thanks for the best podcast around. Can you tell me how carbon dating works?
So carbon dating, we're talking about different isotopes of carbon, and that basically means slightly different forms of the element. There's basically most of the carbon in the world, in the atmosphere, in the planet, is a form of carbon called carbon-12, which means, I think, am I right, Chris? I'm going to get this slightly wrong. 12 neutrons. Is that right?
The atomic number of carbon
is neutrons,
6.
isn't it? It's 6, OK. Anyway.
So that means that in the nucleus you've got 6 protons. And 6 neutrons.
And 6 neutrons. This is Chris giving me my chemistry lesson, which I should remember, but basically there's a heavier form of carbon at a very much smaller percentage in the atmosphere, and that's carbon-14. And that's actually slightly radioactive, which means as over time it breaks down. Now, when you get plants that are photosynthesizing, which we will possibly talk about again today with Beverly, they take on this C14, and they have an amount of it in their tissues in proportion to the amount that's in the atmosphere. But once they die, that carbon-14 starts to break down. And if you can measure the amount of carbon-14 in that organism, you can tell how long ago it died, basically. And it's effective for about 40,000 years. You can actually pinpoint dates from when that animal, if it's the animal that's been eating the plants, it also has C14 in that kind of ratio, and that will drop according to how long it is since it died and stop taking on more of the C14 in the atmosphere. I think that's about right. What do you think, Chris?
I think you hit the nail on the head. Well done. Here's another one from Adam Reynolds. He's 7 years old. He's in Minnesota in the USA. Sorry, I had to say it like that. I don't know why. Sorry, Adam. He says, I want to know why you get brain freeze when you drink an icy drink.
Oh, my goodness.
Do you have that?
I do, actually. Mostly with those sort of frappe coffee
Oh, you do
drinks.
dine out in posh places, don't you?
You know, I love those. You know, kind of
Frappuccino.
That sort of thing. And they're great on a hot day, but do make your nose and your head hurt. No, Chris, I don't know. Do tell me. Do you know why that is?
I get this, and I was so intrigued because it happens to me. This horrible piercing headache right at the front when you eat something that's cold, obviously, or drink something that's cold. And so I started looking into it. No one actually knows precisely why it is, but theories are that this is a form of referred pain. And referred pain means you have damage or pain coming from somewhere in your body, but you feel it somewhere else. So, for instance, people who have a heart attack very often describe feeling pain in their neck or in their left arm, not actually where their heart is. So in the same way as that, you've got the nervous system fooling you into thinking the pain is coming from somewhere else. So what scientists think is that the nerves in the mouth that are very sensitive to cold temperature accidentally trigger the nerves supplying the front of your head into thinking that there's a painful stimulus coming from there, but actually it's coming from your mouth, but you're fooled into thinking that. Another possibility that people have put forward is that when you put very cold things into the mouth, there's a nerve reflex that's to do with regulating the temperature and blood flow through your face and head, because obviously warm blood keeps things warm. If you get too hot, lots of blood, you sweat, and then you cool down again. And it might be that when you put something very, very cold onto the nerves that signal this reflex, that it goes into overdrive and you get blood vessels temporarily opening up too much because they think your head's freezing cold. And in the same way as a migraine gives you that horrible throbbing headache, perhaps that's why you get that temporary, pulsatile, very, very throbbing, agonising pain right at the front of your head, and then it goes away when you warm up again. Who knows?
Indeed. Another email here. We have a lot of listeners in the States and we love to have your support, but this one is slightly different. A techie from India has emailed us. Joe Jenny Thomas says she loves... he's got an E. Joe. He loves to listen to our podcast at work and he's actually just started yesterday and he really loves it. So thank you very much for your email all the way over there in India.
One very quick question. Margaret in Corby, Helen, has a question about frogs. She has some in her garden, and she says they come up to her and she lets her tickle them. She wants to know why they like this. Any suggestions?
It's tickling frogs, I have absolutely no idea. We'd have very, very sensitive, permeable skin, so I don't wonder why they'd want you to touch them. Perhaps they've got some parasites they want you to scratch off on them or something. I don't know.
Time now to cross the Atlantic and catch up with Bob and Chelsea for this week's edition of Science Update.
This week, the topic is climate change, where all the news seems to be bad. And in fact, we'll bring you some bad news later about how climate change may be leading to an influx of mercury in the environment. But first, some good news. We all know that taking public transportation over driving is the right thing to do as far as the environment's concerned. But new research suggests that in some cases, what's good for the environment may also be good for you.
It's an old debate that's been rehashed countless times. Train commuters claim that their ride is less stressful because they don't deal with traffic. Drivers swear they're more relaxed because they're in control. Now, new research on New York commuters supports the train riders' side. Environmental psychologist Richard Wenner of Polytechnic University in New York and his colleagues asked commuters about their psychological states before and after commutes.
And what we found was, first, that train commuting was significantly less stressful than car commuting, that it seemed to be less stressful largely because it was perceived to be significantly less effortful than car commuting, and also because it was more predictable than car commuting.
Wenner says this predictability is key because it means people can relax knowing they'll get to work and back home on time. Of course, that requires that the commuter trains run more or less on schedule, something that's not true in every city. He adds that the effects of stress are not only psychological, but also physical, and the daily commute is a potentially significant but still poorly understood contributor to people's stress levels.
Thanks, Chelsea. Wildfires raging at unprecedented intensities in the north may be unleashing massive amounts of mercury into the environment. The mercury has accumulated harmlessly over thousands of years in the soils of wetlands, particularly in peat soils in northern North America. But Michigan State University ecologist Merit Turetsky says that in just a few decades, forest fires in these regions have more than doubled in size, a result of global climate change.
And I think it's really important to clarify that forest fires don't just burn forests. They also burn other ecosystems, including peatlands. And our data showed that when peat layers within boreal wetlands burn, it releases very large quantities of mercury to the atmosphere, and it overwhelms regional sources of mercury that had been previously calculated.
She says the mercury could disperse over long distances and find its way into the food chain, where it could eventually reach animals and people.
Thanks, Bob. That's all for this week. Next week, we'll bring you a piano piece composed by Mount Etna. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society.
Thanks, guys. More from Bob and Chelsea at the same time on The Naked Scientists next week. In the meantime, if you have any science questions for us, don't forget, you can just send them over by email, chris@nakedscientist.com, and we'll try and get them into the programme for you.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
It is The Naked Scientists with Chris and Helen, and we're going to be talking in a little while about weather forecasting, and we're talking to a real live weatherman. He's at the University of East Anglia. John Law joins us shortly, but first of all, here's Beverly Glover from Cambridge University, who works on plants and has also found out how they're getting up to jiggery-pokery to attract pollinating insects. Hi, Beverly.
Hi, Chris.
Thank you for coming in. Now, what's your work about, and how does this actually get achieved?
Well, what we're interested in is the adaptations that flowers have that make them particularly attractive to pollinators. If you think about a flower, the petals, the bright shiny bit that you like to look at, is really there for only one reason, and that's to attract animals. And so different plants have come up with different ways of making those petals attractive to animals. The one that we've been working on most recently is little miniature lenses, if you like, on the petals, special shaped cells that warm it up a few degrees. And we've been doing some work with bumblebees in the lab, in mazes and flight arenas, to test whether they actually prefer warmer flowers, whether that would actually be an advantage that would mean the flower would attract more pollinators in the wild.
And does it work?
It seems to work. We certainly know that having those lens-shaped cells makes the flower warmer, and that warming effect is strongest at dawn and at dusk. And we know that bumblebees, which are the animals we mostly work with, need extra help at dawn and dusk when it's quite hard for them to get that big fat body off the ground and fly. And so what we've been doing is actually giving them artificial flowers of different temperatures and seeing whether they prefer the warmer ones and whether they can actually learn that certain colours of flower might be warmer than other colours of flower. And it seems that they can. They can work out that some colours are warmer than others.
Because the dark colours absorb more energy?
Well, that would be one way of doing it. And it certainly seems in the wild that, from our very preliminary work, dark-coloured flowers are generally warmer than cool-coloured flowers.
So why aren't they all dark then?
Because there are all sorts of other ways of doing it, and it's not just about warmth. A pollinating animal's interested in being able to spot the flower easily from a distance, so you've got a long-distance visual contrast to the green of the leaves. It also needs to be able to work out where to get into the flower at a short distance, so you've got short-distance visual effects. And there's beginning to be some data from work of ours as well that they actually like the different feel of different flowers, so that tactile effects might have a role too. So temperature's just one part of the bag of tricks, if you like, that plants have.
Why do they like it? Because it's warmer, Beverly? Why should that be more attractive?
For a bumblebee, we think it's about metabolic reward. They need the sugar from the flower to make energy to fly, but they, like you on a cold day, might get more energy more quickly from a warm drink than from a cold drink. It saves them using their own energy to heat that nectar up if the flower's already providing it at a warmer temperature.
And of course the bumblebees, I mean, it's all about being cold-blooded, is it really? That these are not like us mammals who keep ourselves warm. They actually rely much more on their surroundings to get themselves warm and active for the day's activity.
Yes, that's right. There's a lot of evidence out there that many insects will bask in warm flowers just to get the heat. What we've done really that's different is show that just warming your flower up a couple of degrees, warming the nectar up to give a warmer drink, makes the difference as well. It's not just about really big sunbathing, it's about getting a warm drink as well.
How far back in evolutionary terms do you think this goes, Beverly, or is that a very difficult question to answer because there's not a fossil record for plants quite as well as there is for other things?
You'd be surprised, actually, how good the fossil record of flowers is, but it's a difficult question to answer because there are probably a whole range of different ways of warming a flower up, and some of them won't fossilise. So, for instance, tracking the sun, following the sun through the sky, is not something you'd pick up from a fossil, and some plants do that. The cells we've been looking at, the little lens-shaped ones that warm the flower up, we know that around 80% of flowering plants have those, including, if not the oldest flowering plant family that's still alive today, probably the second or third oldest groups have those cells, which suggests it may have evolved quite early.
Because insects have been around for quite a few million years. I mean, a couple of 100 million years, isn't it, for most arthropods-type animals? So does that mean plants have been up to this trick ever since then?
Well, it's an interesting question. There's a lot of debate out there as to whether the flowering plants, which are very, very rich in species number compared to non-flowering plants, actually underwent that radiation into so many species because the insects were also radiating into so many species at the same time. In the fossil record, certainly there are a lot of flowering plants appearing as some of the insect groups expand. And so it's possible that link's been there a long time, but it's quite hard to prove.
I've got some emails here for you, Beverly. This one's from Dirk England. He says, I've got a simple question, but it's been bothering me for a while. Why are most plants green? Sure, it's because chlorophyll rejects green light, but why does it? Because the green part of the solar spectrum is the most intense, and it seems like a waste to reject it.
It's an interesting question. I mean, not all plants are green. There are different groups of plants in the sea that are brown and that are red, and they photosynthesize in just the same way, but they're using pigments that trap different wavelengths of light to get that energy from. So you can obviously do it with other wavelengths. It's not something specific about green. It may be just that something else about the early green sea plants made them more successful than the early red or brown sea plants, and therefore they were the ones that managed to make it onto land and now look like the dominant form. It may not be that green's any better at all. It may just be that the green plants were better for some other reason.
So we could have ended up with a red landscape.
Indeed, or a brown one.
It would have been pretty different.
I've got another one here. It's actually from Japan. This is from Yunka Song, who says, I'm an undergraduate studying biology in Japan. Forgive me if my English is not fluent enough, although I see the English in this email is perfect, better than most of the ones we get from my relatives. It says, my question is, are there any advanced and complex multicellular animals that have chloroplasts inside their bodies or under their skin? I know there are organisms such as Euglena. That's a kind of slime or something, isn't it? Yeah. That carry chloroplasts with them. And I think this would be a great advantage in view of evolution because such organisms will be able to move around anywhere and they can enjoy sunlight.
Not that I know of as their own chloroplasts, but there are more complex multicellular animals out there that pinch the chloroplasts from plants. So quite a few examples in the cnidarians, that's jellyfish and things like that. A little freshwater jellyfish called hydra that pinches chloroplasts out of green algae and keeps them in its own gut and actually lets them photosynthesize and nicks the sugar that they produce. So there are animals that trick plants out of their chloroplasts.
Do sloths count? They get covered in lichen. I don't think that does really count. I don't think they benefit from it, but the three-toed sloths, those slow creatures living in South America, get covered in mosses and lichens, I believe. That's why they look green. But maybe that's not quite what you're talking about.
Beverly, how's your wine? This chap is Ralph Leftwich, I think, is in Oregon in the US, and he says, can you please explain why some Pinot grapes turn into great wines and some don't? Is it down to soil chemistry, for example?
I don't know much about grapes, but it's likely to be down to the chemistry of the grape, whether that comes directly from the soil or from the genetic base of the plant line itself. But the taste of wine comes from a lot of the things we call secondary metabolites that plants produce, the things that they use to protect themselves against predators and to attract animals to eat their fruit. And so it's likely that different lines have different chemicals, and that gives you different flavours in the wine.
Thank you very much. That's Beverly Glover from the University of Cambridge. If you'd like to ask her a question about anything plants, she works specifically actually on these tiny cells that act as lenses and focus sunlight onto the plant to make the flower warmer and therefore more attractive to pollinators. But if you'd like to ask her some questions, 0845 9 25 2000 is the phone number. You can text in on 07786 20 1960 or email chris@nakedscientist.com. And don't forget, I have a teaser running this evening. CFCs, they destroy the ozone layer. But what does CFC actually stand for? I've just heard from Steve in London. He's on the right he's on the right lines, as is Denise. Well done to both of you. Everything to play for. We've got some fantastic radio goodies to give away. Get calling now if you think you know the answer.
The Naked Scientists. Supported by the Wellcome Trust.
Chris and Helen as the Naked Scientists, and time now to cross over to join John Law, who's at WeatherQuest at the UEA, to find out from a real live weatherman how we actually predict the weather. Helen.
Hi, John. How are you doing?
Hi, Helen. I'm very well, thanks yourselves.
Good, thank you. So, we want to know, how can we predict the weather? Yes, what's all this about? Predicting temperature. How do we know it's going to be 19 degrees in 3 days' time? Where do we start off with this kind of thing?
Oh, it's a good question. Weather forecasting is very much like putting together a big jigsaw puzzle. You get all the pieces and you just got to assemble them in the right kind of way. A lot of modern meteorology comes derived from computer-based models which take into account all sorts of equations and parameters and put them together to produce an output. But what we use here is also an awful lot of bench meteorology and looking at basic fundamental physics and working out how that affects our temperatures. So by looking at the thickness of a set level of the atmosphere, we can look at how that would affect. So a thicker piece of the atmosphere would tend to be warmer. So as we can see how that tracks across the country, that would have a bearing on the temperatures as well.
And I think one thing I'm sort of fascinated to find out, how soon can we predict the weather and say the temperature? I mean, can I talk about it in half an hour's time in a particular location or in an hour's time, or do you really have to work in longer blocks of time than that?
Well, with forecast, it tends to be the sooner and the shorter term forecasts tend to be a little bit more accurate. As you tend to go further out into the future, things tend to be a little bit more variable. But the short range seems to be a little bit more accurate, yes.
They're more accurate, so I'm better off to know what's going to happen this afternoon than perhaps the end of next week. I think what we all really want to know, especially here in England, is when is it going to rain, especially in our summer days. It's been gorgeous today, but how do we go about predicting if it's going to rain or not?
Well, a good thing to do is to look at the bigger picture. Looking very close to home, you can't really see much. So if you look at where the weather's going to come from, that gives a real indication of what the weather holds in store. So by looking at things like satellite pictures, which show how the weather is developing up over the Atlantic, for example, we can see it as that moves across us as we go through the week. For example, we've got a tropical storm developing out in the Atlantic at the moment, which is due to come across Bermuda later on this week. But that is going to produce a lot of moisture, a lot of warm air that's going to eventually come across us over here in England. So that's going to have a real bearing on the weather we get.
So you're basically saying it's going to rain next week?
It looks like it might start raining pretty soon.
Oh, what a shame. It has been so nice. So essentially it's all about what happens just upstream of us, and if we can predict which way it's coming in, we'll kind of know what's going to happen where we are. Is that sort of the key, really? That's
exactly it. Looking at where the weather comes from and the air masses that we have, each of them have got very different sources. So, for example, air that comes down from the southwest tends to be very moist and very warm, whereas air that comes in off the continent tends to be very dry. And in the summer, where the continent's quite hot, it's a very warm air. But in the wintertime, when that's quite cold air, that can be really quite a chilly period, especially for us over in the eastern parts of England.
I know, we do suffer from those cold winds here in Cambridgeshire, don't we? Now, I believe we have a question sorry. Actually, I have to say, I'm sorry, John. One of the things we would like to know is when you get it wrong. Do you have a good excuse for why sometimes the weather forecasts aren't quite right? Are we just asking far too much of you to get it perfectly right all the time?
I think the best thing to do is to look at why it went wrong. I mean, there's always a reason why things didn't quite go to plan. If you can work out why it didn't go quite right, first of all, you can sort it out next time. So there are a lot of things that could potentially go a little bit awry. So it's just keeping an eye on things and making sure you keep up to date with the latest weather.
OK, great. Now I believe we do have a caller on the line. Is there Tony from Norwich is there? Hi, Tony.
Hi.
So you have a question for John?
Yes, please, John. Good evening.
Hello, Tony.
I've been hearing a lot about when you get frost come onto the car first thing in the morning, and people say, oh, yes, that's due to the dawn dip, because before it gets light, there's no frost sometimes, then afterwards, when the sunlight comes up, we've got frost on the windscreen. What exactly do they mean by the dawn dip?
Well, I have to say, it's a term I've not actually heard, but we do get the coldest time of the night is actually just before we get the sunshine coming through. So we've lost the daytime heating. There's still a bit of moisture, a bit of heat in the ground, but it's just as we go through right into the early hours of the morning when we do see the coldest temperatures, normally around about 5 or 6 o'clock.
Yeah, well, what's happened in one or two cases is I've had to go away early morning, and I've loaded up the car while it was dark and the windscreen was fine, and then I go back out after I've had my breakfast to set off just about dawn time, and the windscreen's all frozen over.
That's right. You can also get a lot of condensation and moisture and dew, and that's what can cause the problems as well, I would have thought. So it's a combination of the moisture and the colder temperatures that would have caused the windscreen to freeze over.
Tony, thanks very much for that question. Do you want to have a quick go at our quiz?
No, thank you.
Righty-ho. Well, look, thanks for joining us on The Naked Scientist. It's been a pleasure having you with us.
Thank you. Bye-bye.
OK, John, I've got some other questions for you. Paul in South Yorkshire is saying, just wondering, if clouds are made up of water, why do they differ in colour, i.e. fluffy white to darkest black?
That's a good question. The main reason, I think, is the thickness of the cloud. A nice, light, fair weather cumulus tends to be quite shallow at times, but as it gets bigger and bigger and bigger, we tend to see less light coming through the cloud, and that tends to be really, really fairly dark. So you get these big areas of stratocumulus which cover the sky. Not a lot of sunshine gets beneath them, so we're really looking at the shadow underneath the cloud.
Another one here from Doug Gilding. He's in Worcestershire, and he says, given that as altitude increases, temperature decreases, does this mean that when precipitation begins to fall from clouds, it usually falls as snow or sleet or hail at altitude and then melts as it warms and reaches the Earth?
Oh, that's very true in a certain number of cases. Water in the clouds can exist in liquid format, even below temperatures of zero. So it's in the form of supercooled droplets of water. But in very, very thick clouds, where the cloud top temperatures can be around about minus 40 degrees Celsius, most of it does start off as ice. And as it falls down, if the cloud base is still below 0 degrees Celsius, it falls as snow and hail. But as it comes through and begins to warm up, it does begin to melt down, and we actually see it on the surface as rain.
John, one quick question just to finish up here. What's the deal with the Gulf Stream? We hear a lot about this with talk about climate change and so on. Is it really true that temperatures could go down now instead of up in this warming world of ours?
Well, it's true that the Gulf Stream is a very important factor in our weather here. For our latitude, we're around about 9 degrees warmer on average in this northwestern corner of Europe. So it is a very important feature. It feeds a lot of warm air up from the Atlantic. If that were to change, it would definitely have some kind of effect on our weather here, but it would probably be evened up with other effects that are going on with climate change. So at the moment it's very hard to see how much of an effect it would have, but I think it's fairly safe to say that the Gulf Stream is very important, and any change would probably have a certain effect on us.
John, thanks very much.
No worries. Thanks so much for inviting me.
That's John Law from WeatherQuest at University of East Anglia. If you'd like to ask him any questions about the weather, 08459 25 2000 is our phone number. You can text in on 07786 20 1960 or email chris@nakedscientist.com. Remember that we also have our teaser going this evening. What does CFC stand for in terms of the things that were banned to try and rescue the ozone hole? If you think you know the answer, give us a call. I'm just going to flag up. Does anyone know the answer to this? Because I don't. Dennis in Cambridge wants to know where the saying, once in a blue moon, comes from. Is that something scientific? And if anyone can help me with that, I'm stuck. I'd really appreciate your thoughts on that one. This is a quick one, Helen, for you. Peter in Good Manchester wants to know if fish fart. And if so, where do they come from? Because we don't see any bubbles.
Farting fish. I don't know. I'm afraid I'm actually not up to speed with farting fish. It's not a particular area of my research. I think, Chris, you might know about farting fish, don't you?
I remember
Strangely
you
enough.
actually talking about this a while
Chris has
back
such
on
a
the
better
Naked
memory than
Scientist.
I do.
Fast repetitive ticks, which is where they got the name from. They called these things
that's
fast
right.
repetitive ticks, and in
Yes.
fact it's fish blowing tiny bubbles from this structure called the cloaca at the rear end, and they release these things in pulses at a certain rate, and it's thought to underlie some kind of communication.
There you go, communicating by fish farts, and that's fantastic.
OK, if you have any questions for us, then just give us a call, 0845 925 2000. Chris and Helen as the Naked Scientists. And coming up now, we're going to talk to Marcel Visser, who is from the Netherlands Institute of Ecology, and he's going to talk to us about how climate change is having a fairly major impact on how animals that migrate make their way back and forth across the world and how they then reproduce. So, hello, Marcel. Thank you for joining us.
Good evening.
Tell us about your research and how you went about studying this problem.
Well, we studied migratory birds in the Netherlands for a long time, from the 60s onwards. And one thing that we noticed at some point was that the birds were coming in earlier. Well, they were laying early. These are pied flycatchers. They overwinter in Africa. And one thing that was very noticeable is that the birds, when they arrived, they started laying eggs very quickly. In the old days, it used to be 2 to 3 weeks in between arrival and laying, and in recent years has been only a week.
So birds are leaving Africa. They're leaving according to when they think it's the right time to come back. They're arriving, but they're arriving at a time when the seasons have already moved on.
Yes, for the birds it's very difficult to predict the conditions in Europe, of course, all the way in Africa. It's 4,000 kilometers. So the birds use some kind of a cue like day length or an internal clock. And that used to work very well, but now, by the time they come back, spring has advanced already quite a bit, and they are actually just too late to really take advantage of all the food that's around. There's only a very short period, there's a lot of food in the forest. This is quite important to realize. There's only about 2 to 3 weeks that there are really a lot of caterpillars around that they need to feed their chicks.
So how badly are the birds being affected, and is this something we can actually do something about?
Well, in the case of the pied flycatcher, we know that the majority of the birds now have their nestlings in the nest too late. We know that by the time they start feeding their nestlings with these caterpillars, the caterpillars are already on the decline. So that is quite clear. That is one thing we can observe. The other thing we have shown is that there are different areas within the Netherlands or within Britain, and some of these areas have a very early food peak because the trees are early, the caterpillars are early, everything is early. And other areas, usually on the more poor soils, they are all a bit later. And it's very clear that the flycatchers in these early areas are really too late. And what you see there is that the populations are declining. The numbers are dropping, and some of these areas, the flycatchers have completely disappeared. In the other areas, the poorer areas where food is late, they just arrive on time to rear their offspring, and there they're still hanging on. So they're not declining there. So there's a very clear effect of on population numbers.
Do you think that this is going to be confined just to this species of bird, or are other migratory birds apart from pied flycatchers going to be affected?
I think it's a very general pattern. It's very general, especially for the long-distance migrants, the ones that come from Africa, because they have no idea how things are changing here. And actually, the solution, you asked me what we can do about it. Well, the only thing we can do about it is to reduce the increase in temperatures. That's the only thing we can do.
It's not really a short-term solution, though, is it? Because that's something that's been brewing for, a couple of 100 years with the carbon dioxide accumulation. And if we try and stop it now, I'm not sure whether it's actually going to be within a doable amount of time. If
we now reduce our CO2 output by 60%, then the increase in temperature will still be 2 degrees in the next 100 years. That is, that's something we can not do anything about. But if we keep on going on like we do now, it will be 9 degrees. So, and that is not a trivial difference for the birds, because what will happen with these pied flycatchers is that you get some kind of natural selection. The birds that arrive early will be the ones that most offspring, and these offspring will arrive early as well, because we know that it's heritable. So there is some scope for adaptation of the bird, but the rate of adaptation is going to be slow. So if we can keep the increase in temperature at a reasonable level, the birds are probably able to follow that. But if we keep on going like the way we're going, then the increase in temperature will be so rapid that there is no way the birds can keep up.
Just very briefly, Marcel, I've got a question that's come in from Evo Sphere, who wants to know whether man is evolving in return or in response to global warming and climate change. But I suppose a more pertinent version of that question would be, well, are these birds able to evolve fast enough to deal with it?
Well, that's actually the thing we're looking at really in close detail now. Look at what kind of selection there is, what kind of heritability there is. And what we can estimate now is that we can see that they will be able to evolve in time. But it really critically depends how quickly the climate is going to change. These two rates need to match each other, the rate of adaptation, the rate of evolution in these birds, and the rate of change that we impose on them.
Marcel Visser, thank you very much for joining us to tell us about that.
Okay, thank you.
Marcel Visser, who joined us to talk about how the change in climate is causing animals that normally migrate, and they're migrating at the right time of year for them, are turning up at the wrong time, effectively, in the new country where their food has already been and gone, and it's causing devastating effects on their population. Helen.
I have an email here from Deborah Moore in Toronto in Canada. Thanks for emailing us, Deborah. She says that we're the highlight of her week, which is really great. And she says that we saw her through her 9-month pregnancy when she couldn't go running anymore and had to go power walking and would have been terribly bored. But because of our podcast, it managed to keep her going and actually looking forward to her walks. She used to live in England and, oh no, let's not mention the whole accent thing, shall we, Chris?
Probably better not to. Beverly, got a question for you. Les is in Over. He wants to know why French beans make your teeth squeak when you eat them, but runner beans don't. Any ideas?
Not a clue. Not a clue. It'll be to do with what the surface is made of, I guess, but I don't know the difference. Different wax layers, maybe?
So there's some kind of protein or some chemical secreted onto the surface of the bean?
Probably.
It's got to be heat stable, though, hasn't it? It mustn't be washed off in the cooking, because it still happens when they're cooked.
Do they squeak more if they're cooked rare?
I don't know, maybe we should do an experiment. Does anyone know whether... has anyone eaten French beans without cooking them? Do they still squeak on your teeth? Not sure. Had a call from Alec in Norfolk. He says... the saying once in a blue moon, meaning not very often, applies to when you have 2 full moons in 1 calendar month, which doesn't happen very often. So for things that do not happen very regularly, you say once in a blue moon. Sounds plausible.
It does to me, too. Should we stick with the subject of the changing climate and the changing world around us? And as the world warms, the permafrost are beginning to melt, which is allowing bacteria to turn carbon-rich material laid down over 30,000 years ago into greenhouse gas methane. But how much gas is being produced? Well, it's very difficult to quantify because most of the bubbles out from so-called thaw lakes, that's where the bubbles of methane are coming from. But now Katie Walter from the University of Alaska Fairbanks has used bubble traps to measure how much methane is emerging, and it's enough to increase the methane contribution from the northern wetlands by up to 63%.
This work is all about quantifying a new source of atmospheric methane which was previously not recognized as a large and significant source, and that is bubbling from thaw lakes. Lakes where the permafrost is melting and the lakes continue to expand as they melt into that permafrost. That's where they get the name thaw lakes.
So how have people tried to measure this in the past, or haven't they?
In the past, scientists have measured methane emissions from lakes in 2 ways. They measured the diffusive emission, where methane moves along a concentration gradient from the sediments into the atmosphere, and they've done that by just measuring the concentration of methane in the surface water of the lakes. Another source of methane from lakes is bubbling, and that's a much more difficult source of methane to quantify because bubbling is very rare both in space and time.
So what have you done to get these accurate quantitations of them?
We had the excellent opportunity in Siberia to study bubbling because when the ice forms on the lakes in autumn, it's like putting a piece of saran wrap across the surface of the lakes. It traps the bubbles in place as they wobble to the surface, and then they freeze into place in the ice. And we can walk across the ice and map out the distribution of point sources and hotspots.
So you walk out on the ice, you can see where the bubbles are coming up, but then how do you physically work out how much gas is there?
We've constructed bubble traps out of greenhouse plastic and copper wire, and we place those either under the ice or in the summer, when there's no ice, we just place them floating under the water surface, and each trap captures the bubbles that come up continuously. And so we would go out every day and measure the volume of bubbles that had collected.
So in the grand scheme of things, how much methane is this actually contributing to the global environment?
Well, scaling up the type of Siberian lake that we were studying, we estimate that methane emissions from these lakes is about 3.8 teragrams per year. Now, these lakes are only a portion of the northern lakes in general, so if bubbling is something that happens everywhere, then this could be an even much larger phenomenon than just the scope of our Siberia work. And now we see that just adding this small portion of Siberian lakes to the northern wetland emission estimate, it increases it by up to 63%, 10 to 63%.
So what are the implications if you add this to the sort of global warming equation then?
This is a new positive feedback to global warming. Methane is a very strong greenhouse gas, and so as methane is being produced, it is trapped in the atmosphere, increasing atmospheric warming, which then enhances the thaw and the expansion of these lakes further. So today, there is still about 500 gigatons of carbon remaining in this unique type of Siberian permafrost. And it's projected that during the next century, the majority of that will degrade, and that can release tens of thousands of teragrams more carbon to the atmosphere.
So should this provoke a rethink of what we think is actually likely to happen in terms of global warming in the future then?
Well, one component of the general circulation models that is missing is permafrost degradation, and especially with regards to the large pools of carbon that are stored in permafrost. That carbon content is still poorly known, let alone these positive feedbacks to climate change that can happen from permafrost degradation. So, yes, we do have a lot of rethinking and incorporation of these new sources.
Certainly food for thought. That's Katie Walter from Alaska Fairbanks, and she was talking about the University of Alaska Fairbanks. She's talking about, of course, permafrost melting as the world warms up due to global warming, and that's making all this carbon-rich material that's been frozen for thousands of years suddenly accessible to bacteria that break it down and turn it into methane. And because methane's more of a greenhouse gas, the whole thing feeds back on itself and makes the problem even worse. Helen?
I've got a question here from Stefan in Chicago, who says, my friend and I want to give blood the other day, and we're curious how the body knows that it is a pint low and begin to make more blood cells. Chris, any idea there?
That's a good question, actually. It's all down to the kidney, and your kidneys secrete a hormone called erythropoietin, which stimulates the bone marrow to make new blood cells. What makes the kidney do that? Well, the kidney has all these chemical sensors in very, very tiny blood vessels, and it monitors how much oxygen is present in the tissue, and it infers from that how well the red blood cells are working. In other words, how many of them there must be and how well your lungs are working. And if your oxygen level drops a little bit, the kidney assumes that's because you haven't got enough blood, and it makes more of this hormone erythropoietin, and you make more blood cells. And so that means if you go up a mountain, as the oxygen level drops as you go up the mountain, say you were to climb to the top of Everest or something, as a consequence of that, your kidney would say, aha, I'm not getting as much oxygen as normal, I will therefore boost up the amount of erythropoietin, this will make the bone marrow make more blood cells, and this should solve the problem. And that's why you end up with heavier, thicker, denser blood if you spend time at altitude, and that's why athletes like training at altitude, because it boosts the actual amount of oxygen their blood can carry, because they've got physically more red blood cells.
I hope that answers your question, Stefan. And we've got another 10 minutes of the show now, so do give us a call if you've got any questions you'd like us to answer, or if you want to put anything about plants to Beverly or about weather to John. The number is 08459 25 2000. Give us a call and have a chat.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Now it's time to go back to Derek, Dave and Daniel at Hinchingbrook School to find out what's happening with kitchen science. Have you done it? What did you find? Derek, what have you got for us?
Hello there, welcome back to Hinchingbrook School, and we're here with Daniel, who's actually already got his hand stuck in the cold water and the hot water, so he's been kind of getting himself ready to tell us the result. And also Dave here, who's running the experiment. So Dave, I think Daniel's had his hands in there for about a minute now, so do you think you could tell him what to do?
What we've got to do now, Daniel, is take both hands and put them into the middle temperature water.
OK, and tell us what you feel, so go for it. OK, what do you feel?
Well, basically, the hand that was in the cold water has now gone slightly warmer than the one that was in the hot water.
OK, so what, they actually feel different, do they?
Yes. You can really notice a difference.
Yeah, OK, and so, I mean, what do you think's going on there? We seem to have confused your senses. You know, one hand feels different to the other.
I think it's probably something to do with the nerves. Basically, the ones that have been in the hot have got used to being hot. The ones that have got in the cold have got used to being cold. When you both put them in the middle, they both feel different. OK, sounds like quite a good explanation. What do you say, Dave? What is going on here?
Yeah, pretty much most of your senses are relative. They don't actually measure an absolute temperature or an absolute brightness of light. What they do is they measure kind of relative to what's around it. So your hands, they don't really feel how hot it is. They just feel how hot it is compared to your hand. So if you cool the hand right down, then if you put it in something slightly warmer, it will feel hot. If you get the hand really hot and you put it into something slightly colder than the hot, it will feel cold. So your two hands give different answers.
So this heat effect that we've just seen, when will we actually see that in real life, do you think?
If you've ever run a bath, you'll know that you tend to stir it with one hand, but you should always test it with the other hand before you get in, because the hand which has been stirring it will get used to the high temperature, so it doesn't feel nearly as hot as it actually is. So it will really hurt if you actually get in without testing it first.
OK, so you've got to kind of use your other hand, which hasn't actually been getting used to the heat of that bath. And any other ways at all?
Well, I don't know whether your mother ever told you not to wear your coat indoors because you won't feel the benefit when you go outside. It's kind of like that, because you're used to it being really, really hot because you've got the big coat on. When you go outside, you'll feel cold. But if you go from somewhere quite hot and put a coat on outside, it'll feel about the same.
So there you go, you can see the benefit. But of course, we've confused the senses with heat here. Can we do it with any other senses?
Well, if you've been in a noisy room and you go into a room with a very quiet radio on, you can normally hardly hear it at all. But if you sit there for maybe 5 minutes, you can suddenly hear it really loud.
Yeah, that's right. So if you have a tune, likewise have a tune on very, very quietly, then suddenly your ears do get used to it, and when someone calls you across the room, you're like, whoa, what's going on? So there you go. Your senses can very easily be confused because it's all relative. So there you go. Daniel's actually still got his hands in the water. Over the last minute while we've been explaining that, are they getting used to that temperature of water now?
Yeah, they are, yes.
OK, well, there you go. I think you can take them out now. That's a very committed effort there. So thanks very much, Daniel. But did you enjoy the experiment anyway?
Yes, it was very good.
OK, well, thank you very much to you, Daniel from Hinchingbrook School, and also to Dave for setting this up. And that's all from here. We'll be back next week with some more kitchen science, but I hope if you haven't tried that one at home already, do give it a go, because you can confuse your hands and it's great fun. See you next week. Until then, it's goodbye.
Thank you very much, Derek. And on next week's Kitchen Science, Derek and Dave are going to be in Northamptonshire finding out how to move a fizzy drink can without actually touching it. So if you want to be part of that experiment, you'll need to get hold of an empty fizzy drink can and some polystyrene. So one of those polystyrene teacups or something like that. Right, we've got a couple of questions now. Let's have a quick chat to Connor. Hello, Connor.
Oh, hello.
Good evening. Welcome to The Naked Scientist. What would you like to talk about?
I'd like to know, actually, because the light from galaxies takes so long to get here, I was just wondering, can we be certain any of them are still there?
Well, galaxies, of course, are not the same as individual stars. The Milky Way galaxy, for example, contains 200 billion stars, we think. It's about 150,000 light-years across, which means a star on the opposite side of the Milky Way to our own solar system has been travelling for 150,000 years before it arrives at the Earth. Now, the next nearest galaxy to our own is the Andromeda galaxy. That's about 3 million light-years away, so the light that's coming from there is already 3 million years old.
Right.
So it's beneficial, I suppose, that some suns are very long-lived. Suns, like our sun, live for about 10 billion years. So there's more than enough time for light to come from the Andromeda galaxy. But you've asked a good question, because the point is that space is so vast that inevitably light that's coming to us from stars glinting up there in the sky will actually now be signs of a star that's died. So in other words, one day those stars will wink out because they don't exist anymore, but the light's obviously still coming to us because there's a bit of a delay between it coming out of the star and it reaching us. So I think that inevitably there will be some stars, but not a whole galaxy, because galaxies contain billions of stars, and they'll be at different phases of their lifetime, if you like.
Oh, I see you. That's
okay.
Great. Thank you very much.
It's my pleasure. Thanks for joining us on the show. Roger's in Clacton. Hi, Roger.
Hi.
Now, we've got just a minute or two left. Going to be very quick.
Yeah, I had seen this phenomenon previously, but my wife was out on Friday evening about 7:30, and the moon was just coming up, and she happened to remark that it was, exceedingly larger than normal.
Yeah.
Is there a reason for this?
Well, was the moon low on the horizon? Yeah. Yes. Now, this is a classic optical illusion that's often cited by psychologists, actually. The reason they give for this happening is because when the moon's high up in the sky, you've got nothing in your visual system, in your visual world, to compare it with size-wise. So your brain attributes it to being very, very small because it must be far away, because there's nothing in the foreground, because you're looking at an empty sky. But when the moon has sunk down onto the horizon, or it's coming up, for example, at the early evening, then you're seeing the moon close or in context or even superimposed on things in the foreground, buildings, pylons, trees, even people. And your brain is fooled into thinking, and this is what the psychology theory suggests, and perhaps if anyone has any other suggestions, they could come back to me, because I'd be delighted to hear them. But people suggest that because your brain's seeing something in the foreground that it does know the size of, therefore it compares the two things together and assumes the moon must be much larger than it is.
Yeah, but I'd only seen this sort of phenomenon in the autumn time, like...
Maybe it's because of the time you've actually been going home and the time you've been seeing it. But I'm going to have to leave it there, Roger, because I've run out of time.
OK.
But thanks for joining us on the show.
Cheers.
Next week, we're going to be looking at some of the mysteries of the ancients. How did they preserve their dead? Can we work out what these people ate and how rich they were? And is it possible to discover whether some of them came to a grisly end? Helping us to answer some of these questions will be Lawrence Owens from Birkbeck College at the University of London. You have been listening to The Naked Scientist this evening. I've got one other important thing to tell you about, which is that this week my book has launched. It's called Naked Science, and it's a collection of science stories and the answer to questions, a bit similar to what we do here on The Naked Scientist. All you need is a brain, £7.99, and a good sense of humour to enjoy it, although not necessarily in that order. So if you really enjoy the Naked Scientist podcast, then you're going to love this, and I'd be really grateful if you take a look at nakedscientist.com/book. In the meantime, thank you very much Petro Minch and Anna Lacey for producing this week's show, Helen Scales for helping to present it, Beverly Glover from Cambridge University for coming in to talk about how plants give insects a nice warm drink, Marcel Visser, who joined us to talk about how global warming is affecting migrating animals, and John Law from WeatherQuest, who's told us it's going to rain this week. Thanks, John. And as for the teaser this evening, the correct answer was, of course, that CFCs stand for chlorofluorocarbons. Until next week, goodbye.